Isotope Hydrology Division. The erstwhile Tracer Hydrology Division was established in 1979 under the UNDP-aided Project for Applied Earth Sciences Divisions to cater to the needs of the clients, requiring specific studies to be carried out for delineation of seepage in hydraulic structures, foundation studies of power plants and assessment of seepage losses through irrigation canals. With the application of state-of-art equipment and techniques, that is borehole logging and dye tracer technique, this division has also built up the capability for identifying in situ geological conditions, physical and engineering properties of the structures so as to provide economical, feasible and viable remedial solutions with better understanding and accuracy. Central Water and Power Research Station is equipped with portable well logging unit. The equipment consists of a winch with a 200 meters long multicore cable, a micro logger data acquisition system with high-speed data link to connect to a laptop and various probes, namely electrical, caliper, sonic, focused electric, temperature, conductivity and nuclear, comprising of natural gamma, density and porosity, probes which measure different in situ physical parameters. For nuclear borehole logging, radioactive sources such as cesium-137 and americium-241 beryllium are used for density and porosity logging respectively. Radioactive sources are handled as per the Atomic Energy Regulatory Board (AERB) guidelines and by trained personnel only. Radiation survey meters are used to monitor the radiation surrounding the sources. The major objectives of using tracer technique in geotechnical studies is to determine 1. Seepage zones in dams, reservoirs and canals, 2. To locate seepage entry zones, 3. Hydraulic parameters of subsurface flow, 4. Interconnection between solution cavities, 5. Seepage losses through irrigation canals, etc. At CWPRS, we use conventional fluorescent dye tracers including organic dyes like sodium fluorocene and rhodamine B, which are detected using fluorometer. The tracer techniques can be employed by utilizing two methods, namely single well or point dilution technique and multi-well technique. Dudhganga Dam was constructed across river Dudhganga, a tributary of river Krishna in Kolhapur district of Maharashtra. Excessive seepage was noticed in the downstream portion and also inside the galleries of the dam. Further, it was observed that the seepage increased with the rise in reservoir level. Based on site inspection, 8 NX size boreholes locations were suggested at different chainages corresponding to respective monoliths by CWPRS in order to conduct tracer studies and nuclear density logging. Subsequently, nuclear density logging and tracer studies were carried out in two phases at higher and lower reservoir water levels. Figures are showing the excessive seepage through body of the dam. Tracer studies generally conducted at full reservoir level and at minimum available reservoir level in order to delineate the probable seepage path in the inspection gallery and also in the foundation gallery. At almost full reservoir level, the tracer studies were conducted at 4 different locations and the arrival of dye tracer was observed at multiple locations, both on the downstream and also inside the inspection gallery. Similarly, when the reservoir level was at minimum, tracer studies were conducted at 2 locations. However, only at one location, that is monolith number 5, sodium fluorocene dye tracer was injected at RL 591.5 m, confirming the arrival of tracer at multiple locations inside the foundation gallery. In situ bulk density of masonry was determined continuously with depth by nuclear density logging in 8 NX boreholes. The results of nuclear logging revealed that the density of the masonry varied between 0.97 and 3.1 grams per cubic centimeters. The density values that were observed below the design density of 2.35 grams per cubic centimeters at certain depths were attributed due to the presence of weak masonry, probably due to leaching of cement mortar and openings, that is cavities and fissures on the upstream of the dam body, observed during tracer study phase 2. Bhatsa Dam is a masonry dam constructed in 1983 on Bhatsa River near Shahpur, Thane district in state of Maharashtra in India. Due to aging, distresses in the form of seepage and leaching of mortar have been observed in the galleries of the dam as well as on the downstream face throughout the height and all along the entire length of the dam. Hence, project authorities requested CWPRS to conduct suitable studies to decipher the cause of seepage. Accordingly, 8 NX size borehole locations were selected at different chainages corresponding to respective monoliths by CWPRS in consultation with the project authorities for conducting the nuclear density logging studies. Accordingly, the nuclear density logging studies were conducted to determine in situ density of the monoliths. The results of the nuclear logging studies indicated that the density of masonry varied from 1.14 to 3.10 grams per cubic centimeters, and the zones with density values below the design density of 2.35 grams per cubic centimeters were identified as weak zones, may be due to leaching of cement mortar. In both the case studies, the density variations with respect to depth was used as input parameter for structural safety review, and also the in situ mass density was very useful for grout mix design and also in deciding the grout pattern.